Elasticsearch for around 3 years. Worked at a company that did a lot of different things with Elasticsearch in San Diego. We worked with it from an early version. We were one of the early adopters before they had nested aggregations and a lot of the other really cool things that they've added recently. We were running on around a 30-node cluster. We did everything from a custom split testing service to an analytics platform for our marketing data, where we were one of the top advertisers on Google AdWords. So we were doing a lot of data, and we moved from Hadoop. We were doing a lot of Hadoop MapReduce jobs and huge MySQL database, which was a pain to query. And as soon as we moved to Elasticsearch, it was a godsend for both querying and the speed of indexing and search. So from there, I moved. Me and John built a Meteor application for a fast company that was real-time journalism software, and we used Elasticsearch to search through articles for full-text search. And now we're working at 3Ring, where we use Elasticsearch to search through student documents. It allows teachers and school admins to search through all of their students' documents, so they can make real-time decisions about how they should apply new learning lessons, and make decisions based on that data. So we're going to talk a little bit about how we use Elasticsearch with Meteor and some of the core concepts around Elasticsearch. So what is Elasticsearch? A lot of people just think it's just for search, but it isn't. It's also great for analytics and logs. If you want to dig into your logs, using Elasticsearch with Logstash is amazing. You can answer a lot of questions about your business that you didn't have access to before, and the queries were just way too long to even think about doing. It's built on top of Apache Lucene, and so each shard in Elasticsearch is basically a Lucene index, and Elasticsearch provides the APIs on top of that to really make it useful and easy for developers. So you're not going to use Elasticsearch as your general database. It's not like a transactional database like Postgres or Mongo or MySQL. It's, in my opinion, best to use alongside a database like that, using different data synchronization techniques to river or copy your data and maintain either a denormalized copy of it or an exact copy for aggregation. And the way they built it is really developer friendly. It's all Rust based. There's official libraries for most of the languages that you're probably thinking of using, from Go to JavaScript. And it's all JSON based, so JSON in, JSON out. The query DSL is all JSON. The mapping, everything, all the configuration is all done in JSON. So why use Elasticsearch alongside MongoDB? One of the main reasons, or one of the best features, is you're not hitting your primary application database for really complex queries. So if you're using something like, well, I guess everyone here is using Mongo since it's Meteor, but you're not slowing down your Mongo cluster to try and answer these really in-depth questions about your data. So you're offloading that onto Elasticsearch, which is awesome. So your application is still performing normally, and you can still do these really complex aggregation queries. All the APIs around Elasticsearch are amazing, and you can dig into them for weeks and weeks before you really understand them all. I'll go into tokenizers a little bit in a little bit, but you can create custom tokenizers, and that's basically how it breaks down strings into individual terms and then indexes them for quickly querying them. It has a highlighting API where you can highlight the search results. Like if you guys, I'm sure you guys use like GitHub or Stack Overflow, and you can see they're both users of Elasticsearch, and you can see where GitHub like will highlight a line or a block of code or different things based on your search terms, and they're using Elasticsearch to do something like that. There's a really cool new API and endpoint called Suggest, or the suggestion. And what it does is when you provide your mapping for your index, which I'll go into in a little bit, you also provide a suggestion object which basically map out how this different text term can be broken down into pieces, and then you can do something like an autocomplete where, say if you're searching for property, you can do something like a beach cottage in New Mexico, and it can do something like autocomplete that in like an Airbnb type of way, where it says you type B, and it says beach cottage in Mexico, which is really cool. It's all stored in memory. And also the scoring algorithm and the scoring functions around Elasticsearch are the best scoring functions out of, I think, any type of search engine database. You can do anything from like weighting different fields. So say in this property example, if a pool is more important to users rather than say something like a feature like a Wi-Fi in the property, then those properties are weighted higher in the search results. And that's actually a really basic example of scoring in Elasticsearch. You can get really, really fine-grained with. Another good example is, say, you're searching through articles, and it's more important to have, say you're searching for the word tree, and you have the title that says the tree city, and then you have another document that has like a content block rather than title with the tree. It's more relevant for that document with it in the title. So you can score the title field higher than the content field, and it provides, it's all based on how relevant that document is to your user. And so Elasticsearch is all a distributed architecture. It's recommended you start with a minimum of 3 nodes, just for sharding and replication purposes. It's all built on top of Lucine's inverted indexes, which I'll go into a little bit. And yeah, it's queries that were taking you hundreds of seconds will now take a couple milliseconds to answer huge questions. So how do we use this with Meteor? Since a lot of people think Meteor is limited to Mongo or now Redis, but in reality you can use any database you want as long as you write a package to handle that. And some of the important things to remember is you're not going to want to publish your real-time results like polling or tailing the op log, something like that. You're not going to want to do that with Elasticsearch, just because you're going to want to use Elasticsearch to answer larger questions. And this is not going to function as a replacement for MongoDB in your application. It's going to stand beside MongoDB. Some of the package to integrate Elasticsearch, one John and I built pre the 1.0 package system was it was just called Elasticsearch before they had the namespaces. And basically what we did was expose the official JavaScript Elasticsearch API to your application, also providing some river functions. And I'll get into rivers in a second. And we also provide some Mongo Meteor methods for an easier interaction with Elasticsearch. We're now, in the last couple days, we've been working on a new package for Elasticsearch, which we'll go into in a little bit more detail, but we're really excited about it. It's going to provide the integration. It's going to get the best of both worlds of the real-time op-log tailing of the Mongo documents with the speed and robust query language and features of Elasticsearch combined into one. So there's a couple different data synchronization strategies and or rivers, and what this is how do we get a million documents from Mongo into a usable format in Elasticsearch? And can go through a couple of those. Your basic method is just an Elasticsearch river, and there's one on GitHub called Elasticsearch River MongoDB. And I've used this pretty extensively. The best use case for this river is, in my mind, is a one-off. So if you want to river a collection over, it works really well. But if you're maintaining the synchronization for long periods of time, the river might not be your most robust way to synchronize your data. My last company, we had like a queue in between, RabbitMQ queue, and used our own custom synchronization application we built. There's Compose. How many of you guys use like MongoHQ or Compose? Is awesome. They have their own hosted service, and now they've open sourced it called Transporter. So if you're on Compose, you can easily spin up an Elasticsearch cluster and click their create a transporter that does continuous synchronization, and it will automatically keep your Mongo cluster in sync with your Elasticsearch cluster, which is an awesome service. Or if you want to implement it yourself, it's written in Go, super fast. Another way that we've seen, and I think some other companies use, was Respondly, and I think the package Easy Search uses this. It's using manual collection hooks. So on your inserts, your updates, and your removes, you can manually control how that affects your ES data. And another thing that's cool about doing the synchronization manually is if you want to do denormalization, which is basically, say I want to include, I want to take joins from my MongoDB and I want to combine them into one record in Elasticsearch, which is much faster for querying and doing aggregation functions. This, using a custom method, makes more sense. So, building a better Meteor search. This is where we, sort of me and John have been spending our last couple of days just kind of exploring how we can better use Elasticsearch with Mongo for search and Meteor. And the sort of idea John came up with was, what we were doing is we were displaying the published results and ES results right next to each other. And we noticed, well, initially, of course, like the ES results are coming back super fast. And then we wait for Mongo to publish the actual documents and keep those up to date. So we thought, like, how can we initially display the ES data, but then use the real-time tailing and updates from Mongo to keep the data in real time. We'll show you an example. So what we did is we sort of combine the result set. So we're first publishing out the ES data as in mini Mongo. Right.
It's a Meteor. Just an RPC.
What we're going to be doing.
Yeah. Yeah, well, Elasticsearch is RPC.
Yeah. Yeah, and so what mini Mongo does, so we have the documents in mini Mongo, and then we're doing pub subbing the changes of certain fields from Mongo. So say you have a search result that says, I can give the example. Here, I'll just show you the example that we kind of came up with here. So this is just a data set we found online. It's car emission data from the UK from like 2001 to 2010. And what we're doing is using ES to, let's see if it's still up here. we're having some connection problems with this. All right, cool. There we go. Just a refresh. But as you can see in the red, we're returning the instant Elasticsearch results, and this database is pretty big, so it takes a while to publish. We might be having some. John, take a look at that. Yeah.
Hey, just a quick question. How do you feel about taking questions from the audience during your talk?
Feel great, yeah.
Okay, so anybody that has a question, feel free to raise your hand. And Michael, you said there's a microphone on the table?
Yeah, hold on, let me grab it.
Okay, so we're going to have a microphone there. And I think there are a bunch of people that actually did watch the basic intro.
Okay.
So like basic stuff, like feel free to read through. I probably should mention that.
Okay, awesome. Yeah.
All right, thanks.
Yeah, sure. Did anyone have any questions? Sorry. Sure.
First question, how does Elasticsearch play with Meteor security features?
Yeah, okay. Like the allow macros?
Yeah. If you're not signed in, you're still querying Elasticsearch.
So we're using Elasticsearch not from the client side, but from the server side.
Repeat the question.
Oh, good question. How does Elasticsearch play with Meteor security features? And the answer to that is we're querying Elasticsearch from the server side through a Meteor method. So the security functions don't really come into play, and in terms of that, the only security you would provide would be through the Meteor method, based on the access of the Meteor user through the ID in the method. So awesome. Okay, cool.
So yeah, so you can see you can see the when we remove the query. Yeah, so the red is the Elasticsearch results, and the blue is actually real-time results published by Meteor from Mongo. So first, we're returning a static data set from Elasticsearch, and following that, we're taking the IDs and gathering them into an array. We're passing them back to a subscription, which is returning a real-time publication of the query, or of the results that we got from the ES query. So essentially, you can get a really fast and complex search, and then you'll be subscribed shortly thereafter to real-time updates that you want for that result set, and those things will update the data in real time. So you can have, like, I don't know if you guys have used, I mean, I'm sure everyone who's used Meteor has used Atmosphere probably. So the results on Atmosphere, a lot of times you'll get them, but you'll notice that if you re-add a package, like the number won't change immediately because it's not being published in real time. But in this case, you could do something like that, but you'd just be using Mongo and Elasticsearch together to get the best of both worlds.
Could you ask if everybody can see that in the back?
But yeah, is this big enough for the people in the back?
You want to make it bigger?
Is that big enough?
No, it's beautiful.
Beautiful?
Yeah.
Perfect. Yeah, and some other features that you can benefit from Elasticsearch in this use case is, for example, text highlighting. We didn't have enough time to implement it, but you could use text highlighting, something that you couldn't do, or that isn't as robust in Mongo. You could combine that text highlighting with the document that you're getting from Mongo. So you get real-time emissions, or something more useful like real-time comments or posts. With the text highlighting,
so we can show you, we'll take these results. We'll just manually update the emissions data to this result.
You should move that up because no one will be able to see that.
Okay, so we're dealing with this, you guys see this result here? Yeah. Page 24. So now it's just reactively updated. This is using the results set from Elasticsearch, but we're now fully real time. These changes are being communicated back to the database for Mongo. If you have your ribbering hooked up properly, or you have some collection hook that's sending updated data to Elasticsearch, your subsequent search will reflect the updated data as well. So it's pretty awesome. I can just keep doing it. And it'll go up, it'll shift above this one in a second.
You can imagine something like a leaderboard example where you have a billion people in the leaderboard, but you still want to have real-time rankings in your search results. This sort of example would be useful for that.
So it'll just see it now it's on the top.
And this is going to be a part of the package we're releasing.
It's really simple with the package to set that functionality up. We'll have a client-side templating component to it that basically does it for you. You'll probably notice, like, yeah, you'll probably notice like these loading messages and things that are going on by the search bar. Like those loading messages, that stuff's already active, and there's like a trigger basically in the template that says that when the Mongo results exist, then replace the ES results with the Mongo result.
We're also going to be including the autocomplete using Elasticsearch's suggestions. Cool. Yeah. So after search, another great way you can use Elasticsearch with your Meteor application is logs. And a lot of you guys, how many people are storing their logs with their Meteor application? Yeah. Once you go into production, one of the most important things for you to do is to store those logs and in a organized, detailed fashion. And Logstash, using whatever log or package you want, Winston's a great one for Node because it provides different namespaces and log levels, and then it has transporters that take those logs and send them into Logstash or Elasticsearch. And if you're doing detailed logs in your application, you can find problems before you have to experience them yourself, or like your support team is getting hit up daily about this problem. You usually know about it beforehand. Or if you're having a problem with like one node in your 18 node cluster, it's easy to find like, okay, that was node number 5 that is having issues. And yeah, there's a service or a cool front-end application called Kibana that the team at Elasticsearch maintains now. And I'll go into that in a little bit, and it allows someone who doesn't really know the details of the Elasticsearch query language to dig through the data in a way that they can answer larger questions about your business, such as, there's a lot of different types of questions you can answer. Say, people browsing from iOS are 10% more likely to convert than Android, and then you can go and look at Android and say why is that the case, and it helps you scale your business in a micro.
Because without that,
Okay, we're going to hurry a little bit.
it's so hard.
Yeah. We'll release this online so you can kind of get a little bit more detail into Elasticsearch. But one of the coolest new functions since 1.0 has been the nested aggregations. And I was building an analytics system at the time, so this was just blew my mind. You could do as many nested aggregations and buckets as you want. So I was building a report to find lifetime value of customer. We had millions of customers, and we had a lot of different pricing strategies. So and like 10 different products. So I could dig in and say, this cohort of customers who signed up in March of 2013 with this billing plan, after 6 quarters of billing, gave this many refunds or brought in this much revenue versus another cohort of customers that with a couple different variables, and to make a business decision on which pricing strategy would be the best. Really like complex questions like that are fairly easy to answer in Elasticsearch with nested aggregations. We'll go through a quick list of the tools. Head is sort of the go-to plugin that there's a lot better tools now, but it was the go-to plugin for browsing, for basic cluster management at first. Now there's HQ, which is a little bit cleaner interface. It's kind of bootstrappy. Kibana, Logstash, Shield, and Marvel are all from the Elasticsearch company. And I highly recommend checking out their website. Documentation is great, and there's a lot of awesome videos and resources out there. Shield is a new one. It provides security, user-role access for Elasticsearch. Let's see, I think we're almost done here. Yeah, if you want an easy way to play around with Elasticsearch, jump on Compose. You can spin up a cluster in about 10 minutes and have your data riveted. Yeah. I can show a quick example of like answering a question in Kibana, which sweet. So this is on the same cars database, and we can so we're going to go ahead and add a manufacturer terms pie chart, and sweet. So instantly we have a distribution of manufacturers among these gigantic record database of cars, and then we can click these and dive down into that data to make analysis. And what we'll do here is a quick hits panel with the emissions. Let's do stats. Cool. So we're doing it now. We're gonna change that to a mean.
So as you can see, it's kind of ridiculously easy to use Elasticsearch, and I think this also kind of shows a good example of how your use of Elasticsearch would end up being different than, for example, your use of MongoDB.
So instantly I can dive into my data and make insights into the CO2 emission of different manufacturers, or if I wanted to add another pie chart for models or for maybe years that the cars were made, I can play around with that. And this way of exploring data is a little bit different than sitting there and querying, because you make some observations that you wouldn't really even think to come across if you didn't have an interface like this. So it's really cool. Cool. Yeah, I don't know. Should we go into Q&A? I can go through a couple more tools. Or...
Yeah, let's go to Q&A.
Okay, cool.
So if anybody has questions, raise your hand, I'll pass it on over. I could kick it off. What you just showed with Kibana, is that the analogous part of MongoDB would be like the aggregation?
Aggregation pipeline.
Okay. And you probably picked this on purpose, but the cars database, that's publicly available.
Mm-hmm.
And what you were just doing was very similar to what like cars.com has on the left side over there, where you can like filter down.
Mm-hmm.
That's a that I know for sure that they paid a lot of money for that, because I know somebody that works at cars.com, so it's amazing that you can do that for practically nothing.
Yeah, it's pretty incredible. I think I got this database, downloaded it, spun up an ES cluster, wrote it from Mongo, and started making insights in about 5 minutes. So the speed that you can get started is really, really quick.
Cool. You have a question?
Yeah.
When you were doing the updates, the whole mechanism to send back the updates are just going to the MongoDB, or you were sending it straight to Mongo and then to the Elasticsearch?
It's just, yeah, that was just, okay, yeah, so you're saying when we were doing the updates in the browser console, was that going just straight to MongoDB, or was it going back through Elasticsearch and then back?
Yeah, or both.
Yeah, so it's what you're seeing in the blue background there. The blue background represents MongoDB published data, like a real-time stream of data from a Meteor server on the client. So when we're updating things in the browser console and they're reflected here like that, that's using Meteor's built-in MiniMongo client-side database emulator. So that, I don't know if you're familiar with that, but that brings the full.
From that point on, from the Mongo collection on the server.
Right, so from that point, so that would synchronize that change back to the Mongo database, and whatever you have that's watching your Mongo data and sending it out to Elasticsearch to propagate changes, would sort of hopefully immediately send that update out to Elasticsearch so that it would keep it in sync. So then the next time you ran the search, they would reflect that change, even though it's hitting Elasticsearch first, like everything would still be in sync. We don't actually have our river hooked up properly in this example, so I can't show you how that would be reflected. But I think if I do this again, it might show a discrepancy between the two. Where is it actually? Yeah, so you see that flash where this thing on the top wasn't the same. I'll do it again just to. So, yeah, so you can see there's a discrepancy there in the data because it didn't actually get rivered over, because we haven't picked that up in this example yet.
Anybody?
Yeah.
I'd like to hear about the more tools. You said there's more to say about that?
Yeah, I can talk a little bit about the Elasticsearch has what they call plugins, and they're really easy to install if you have your own Elasticsearch locally or on your a node. A couple of cool plugins. One is Paramedic, and what it does is use sort of D3 cross filter type of display where it's showing the usage of the different nodes over time. This is more for like an like a back-end type of operations, yeah. This is one I talked about, which is HQ. And what this allows me to do, right now I'm looking at node diagnostics, but what I can do is, I can see I have 15 successful shards. I can dive in and say, okay, the status of my cluster is green, which means all good to go. Normally, if your cluster is in a red state or in even a yellow, you want to stop your river or your however you're getting data in DES and hold it in something like RabbitMQ, and then once that cluster is back to green, then start writing documents again. Yeah, a lot of these are for operations, like you said. This is head. This is kind of like probably the first plugin you'll install and kind of get familiar with queries and just kind of browsing through the data and basic cloud. Here you can see the visualization of the this 3-node cluster with 5 shards replicated entirely across each node. So if one node goes down, these shards are still available, and then when it comes back up, it automatically gets back in sync.
And what was the name of that?
This is called head. And there's a bunch of other ones that are more specific towards different use cases. So definitely check out, do some searching around Elasticsearch plugins.
Another question. So for us, we have a request for user search. I don't know why people want to actually search users for whatever reason, but say they do. Okay, so how easy would it be to convert from our existing MongoDB implementation to something that can do like an autocomplete of users? And there's some caveats there, right? So not everybody has access to all users, so they should only be able to search within their kind of universe. And also, we have different fields in the MongoDB database that should all be searchable. So first name, last name, job title, name of which networks they actually have access to, that kind of thing. What do you think?
Can you also repeat there's specific fields you want to return? Is that the last part?
No, so it would be just search for John, and then we return all the Johns that they have access to, or some list of them. Or it could be search for custodians or principals or something like that, and then show those. So being able to search across multiple fields, I think, is probably a pretty common use case for Elasticsearch.
Sure, yeah.
Is that an advanced thing? Is that a simple thing?
Super simple thing for multiple fields. So the question was, number one, searching for users based on the access rights that you have into those users, and number two is searching based on multiple fields. And Elasticsearch makes it really easy to search across multiple fields using their query DSL. The easiest way to probably do it is a pool query, which can take in multiple different things. You could do like pool with 2 nested shoulds, and you could say pool should occupation teacher, or pool must occupation teacher, and then you can also do something like name. It's basically an array of different queries that you're.
So that's setting up the shard, is that right?
No, that's just in the query DSL.
Okay. So before that, there would be a step where you kind of point Elasticsearch at the data.
Oh yeah, sorry. So for the rivering or the data synchronization, you can choose. There's a lot of different methods of how you want to replicate that data into Elasticsearch. The easiest is a plugin that's just a river, and all you do is say, okay, I want to river from my local database the users collection. I want to river that into the say the users index in ES. Click start, and it's done in about 5 seconds.
Awesome. Cool.
Something you probably have sorry.
Yeah, there's lots of different options
there
for
are
security.
different options for security. For example, if you're using Meteor methods to receive a request and then hit Elasticsearch, return the results, you could analyze the query, and you could stop people from trying to access things they can't access based on their role in the Meteor user accounts.
You could pass in like an array of IDs that they have access to, or filter the results after they get back. Because probably the best way is passing in the IDs, just because then you actually get the results scored with those included in them.
Cool, and then as far as examples of Meteor plus Elasticsearch, can you point us to some cool ones? Great ones?
I believe in production, I think it's called Respondly.
I think that's the company
Respondly is
who gave the basic.
the basic top. Respondly is a good example of their search is following Elasticsearch, and it's built in Meteor. It's one of the bigger Meteor applications. So.
Actually, I meant open source examples.
Oh, open source examples. We're going to release a couple in the next few days. I don't know how many
Meteors.
there are.
Yeah.
I don't.
Well, there's the easy search. Right?
Easy search is a great. If you want to get started, you can't really do a lot of the awesome things with ES. It's basically just a search. If you want to look at easy search, it's a good package to check out to review well.
Okay, cool. And what we'll do is we will get the information of these examples, and then when you guys release your new ones, we will update the meetup with the links, so you can have access to that.
Awesome.
All right, I think that's about all the time we're going to do for this. So thank you very much, Andrew and John.
Thanks for having me.
By the way, the company we work at is hiring developers right now. So if you are a talented dev and you love Node and Meteor and Mongo, and particularly if you have full stack skills, we'd love to hear from you. We have awesome benefits and a lot of other perks. So, yeah.
Thanks so much.